Hello students, now we are discussing the next concept of the chapter, some basic concepts of chemistry, that is laws of chemical combination. In the previous topic we discussed matter, classification of matter based on physical and chemically. Now we are discussing the continuation part of the same chapter, that is law of chemical combination. See, chemistry means it is nothing but the reactions. Why this laws of chemical combinations plays a vital role are very important. There are different reasons. The mainly, if you take any of the chemical reactions, they should follow either any one of the laws, or it should follow all the laws. So these laws are classified into mainly the law of conservation of mass. This law was proposed by Lavoisier in 1785. What is the meaning of law of conservation of mass? This is a basic law. Law of conservation of mass. This is a first law or basic law. Let's start with a simple example. So you have taken 100 rupees from your father to buy a notebook. See, the cost of notebook is 60 rupees. You have 100 rupees. For 60 rupees you got book. You won't come back just by taking book. What you do? You will stay and you demand for change. Why means you have given 100, the cost of book is 60, remaining 40 should be taken. Now if you observe carefully, you have 100 and you have taken 60 rupees book and you have 40 rupees. If you add this to book and change, you will get 100. Before you have 100, now also you have 100. But out of 100, 60 cost book, remaining is 40. So it easily or it implies how much you have in the beginning, how much is left at the end. It should be balanced. It should not exceed or it should not decreases. If it is exceeding, some mistake is there. Either they have given extra or you have taken extra. If it is deficient, here you have 100, it is 90 rupees, the change is not given or the cost may be different. So it is not balanced. In the same way, this chemical reaction also works. Let us start with a simple example. What is the meaning of law of conservation of mass? Law of conservation of mass states that matter can neither be created nor be destroyed. There is a simple definition. Or in a chemical reaction, the total mass of the reactants or reactant should be equal to sum of the mass of product or products. This is a very simple definition. Let's start with an example. Matter is neither be created nor be destroyed. Means whatever matter you take, it is impossible to destroy. but it can be interconvertible from one form to another form. This is possible, but it is difficult or impossible to destroy that matter. For example, how this is explained? By taking a simple example. You take CH4. What is this? It is a methane. Methane. Okay, this is a compound. Now it is subjected to a process called combustion. Combustion means burning in presence of oxygen. This process is called combustion. Oxygen, see here you get two products. One is carbon dioxide, another is water. Carbon dioxide and water is formed. If you observe, here carbon is 1, here carbon is 1. This is balanced. You take oxygen here, here 2 oxygen, but one more oxygen here. Oxygen is not balanced. 4 hydrogen atoms are there, here 2 hydrogen atoms are there. Take 2 molecules of water in the product side. Now oxygen is 2, from carbon dioxide another 2, total 4 oxygen atoms should be there. But here we have only 2, so we are taking 2 moles of oxygen or 2 parts of oxygen. Later we are discussing in terms of moles. Let us discuss in a simple way. So you have taken 1 part of methane and 2 part of oxygen by mass. This product is obtained. One is carbon dioxide, another is water. This is in a molar ratio. So CH4 methane, the molecular mass of a methane is 16 because carbon, its atomic mass of a carbon is 12. Atomic mass of oxygen is 1. 4 atoms of oxygen are there. So 1 into 4. It is equal to 16. We know that mass is always expressed in terms of a grams, kilograms and all. In this we are using grams. That is a gram molecular mass, 16 grams. And oxygen is there. So 2 parts of oxygen. 2. Let us write 2. The atomic mass of oxygen. You take 1 atom of oxygen, its mass is 16 units. So we can write 16 plus 16 because we have 2 atoms. Atomic mass is mass number is 16, another is 16, it is 32. So gram molecular mass is 16 plus 16 plus 16, 32 into 2, it is 64 grams. These are the reactants. So reactants usually we are writing left hand side followed by arrow mark and the products right hand side. What is the total mass of the reactants? We have a 2 reactants. One is methane, another is oxygen. Its mass is 80 grams. The total mass of reactant is found to be 80 grams. So we got 2 products. One is carbon dioxide, another is water. If you take the carbon dioxide, the mass of carbon dioxide is 44. So carbon mass and oxygen mass we are combining, that it gives a molecular mass, it is 44 grams. Mass of water, 1 molecule water mass is 18. We have a 2 moles, 2 into 18. The total is 44 plus 36, which is equal to 80. Just observe here. The mass of reactants is equal to mass of products. So there is no loss or gain. The mass of reactant is equal to mass of product. Any chemical reaction should follow this basic laws. Suppose if you get 87, what it mean? The mass is gained in the product side. So in the reactant side, some of the reactants are missed. Or if it is deficient, instead of 80 grams, if it is 70, 10 grams of mass is decreased means any one of the product we have missed or it is not identified. So it helps in the identification of products and the chemical reaction. This law is said to be law of conservation of masses. So let us take another example, very simple example. See, carbon plus oxygen to give CO2. So this is an atom, this is a molecule, you got a carbon dioxide. Carbon, one atom, the mass of a carbon is 12 grams. Oxygen, the mass of one atom oxygen is 16. We have a 2, so 2 into 16, 12 plus 32, which is equal to 44 grams. You have taken two reactants. How many product we got? We got only one product. Just look here. Is it following law of conservation of mass? Let us see. Carbon, atomic mass is 12. Oxygen, 2 into 16, which is equal to 44. See, mass of reactant is equal to mass of product. This is following law of conservation of mass. This is a preliminary or fundamental law. Okay. The second law we have. I hope you are familiar with the law of conservation of mass. It was proposed by Lavoisier. The law states that matter is neither be created nor be destroyed. This is a definition. In the other way it can be explained. In a chemical reaction, the total mass of reactants or reactant is equal to total mass of product or products. Total mass of product or products. This is called law of conservation of mass. Now we are discussing very important laws. That is law of constant composition or definite proportion. What is the meaning of law of constant composition or definite proportion? Usually these topics are very important for NEET, CET as well as board exam. They will give certain examples. You should identify which law it is. So for a given reaction, which law is applicable or which law it is following, it to be identified. You should be very careful. Based on this, we have some numericals also. In the later classes, it will be discussed. So law of constant composition or definite proportions. It was proposed by the Proust. It states that all pure sample of the same chemical substance or a compound contain the same elements combined in the same proportion by mass. Same proportion by mass. This is a definition. By taking an example, it can be explained in the simple way. Just take a small example. See, here one example is given tap water and mineral water. Tap water, the source is, it is obtained through a tap. Mineral water, it is a processed and it is also given to you. Both are water. H2O. So I said mineral water. Mineral water. Tap water. You had few more examples. Glacier water. Glacier water. Sea water. Sea water. Rain water. Now just observe carefully. Here the sources are different. It may be a glacier, it may be sea, it may be ocean, it may be rainwater or tap water. But if you come to chemical composition of a water, its formula is same. H2O only. Irrespective of its source, method of preparation, the composition of the compound by elemental ratio by mass remains same. This was given by law of definite composition by mass or definite proportion by mass. So this is one simple example. Irrespective of the sources, if I ask you what is the formula of river water, you won't say different. You will say H2O only. Why? Source is different. When it comes to chemical composition, H2O is its formula. 2 parts of hydrogen and 1 part of oxygen, or 2 atoms of hydrogen and 1 atom of oxygen, it is combined to give water. It is a glacier water, tap water, river water, or any sort of sources can be taken, but the composition remains same. So this is given by law of definite composition by its ratio of mass, or definite proportion by mass ratio can be considered. Example, this is simple example. You take another example, very easy example. If I ask you, give the sources of carbon dioxide. How carbon dioxide is obtained? We know that carbon dioxide is obtained by burning fuels. Okay, fuel is burnt. You get carbon dioxide. Expiration means exhaling of gas, or exhaling of carbon dioxide is called expiration. It's a part of respiration. Here also you are getting carbon dioxide. And decomposition of calcium carbonate, CaCO3. This is a salt. What is a decomposition? Later we are discussing a definition. Just heat to around 1000 degrees Celsius. High temperature you heat. When you eat this, you get CaO and CO2. Here also you are getting carbon dioxide, but the process is decomposition. Here the process is combustion. In the second, the process is expiration. In all the 3 cases, the product obtained is carbon dioxide. If you observe, the composition have not written any different formula. It is CO2, CO2, CO2. Then what it implies, if you take a compound, irrespective of its source, method of preparation, the composition remain same. This is given by law of definite composition or proportion by mass. This is the second law. You will get MCQs or questions for NEET and JEE on law of chemical combination. Very important topic. Later it will be discussed by taking different examples. Now we are shifting to another law, that is third law. There is no sequence. to remember, you can explain or you can remember the law of definite proportion followed by conservation. It is not like first law, second law and third law, but this is a third law of multiple proportions. What is the meaning of law of multiple proportion? Just take example. Later I will explain. Law of multiple proportion. Fine. Don't go for definition. Take an example. Look here. H2 means you have taken one molecule of oxygen and half O2 means one oxygen atom or half mole of oxygen molecule. Both are same. Half means you will get O only. See what is the product? H plus half O2 gives water. Look into its mass proportion. Hydrogen. We have two atoms of hydrogen. Atomic mass is 1. Two atoms are there. Being it is a molecule, so gram molecular mass is 2 grams. Fine. Oxygen molecule, its molecular mass is 32. Half, which is equal to 16. 2 grams plus 16 is equal to 18 gram molecular mass. 18 gram molecular mass total. Okay, because it should follow of conservation of mass. So water, if you combine, you get 18. You are getting 18. That is a gram molecular mass of water. If you look into this ratio, it is 2 grams, 16 grams. 2 grams, 16 grams and 18 grams. It can be written 1:8. 1:8. Otherwise, if you remember like this, 2 grams is combining with 16 grams of oxygen to give 18 grams of water molecule. 18 grams of water molecule. Take another example. Take another example. See, H2 plus of O2, this is previous one, H2O. Observe here, H2 plus O2 giving other compound. It is not H2O, it is H2O2. What is the difference? Here the hydrogen and oxygen is combining to give water. Here is also hydrogen and oxygen, but it is not water, it is hydrogen peroxide. You got a different product. Why you got a different product is a question. Very simple. Just observe. Here you have taken 2 grams, it is 16 grams. Here it is same 2 grams, but is 32 grams. Oxygen mass is 32, hydrogen mass is 2. If you observe carefully, what is a common thing? Here the mass of hydrogen is fixed. Other is varied, oxygen is varied. As a result of different mass of oxygen which is combined to the fixed mass of hydrogen, we are getting different products. Here hydrogen mass is fixed in both the case, but the mass of oxygen is different. As a result, we are getting different products. This statement can be given in a simplified way, that is through law of multiple proportion. By taking this example, how the definition can be framed. First thing, it was proposed by John Dalton. Law of multiple proportion. It states that when two elements A and B combining together to form more than one compound, the mass of A, which is separately combined with a fixed mass of B, are in a simple ratio. Here also it is following simple ratio. Here 1:8. In another case, it is 1:16. 1:16. It also follows simple whole number ratio. But the ratio by mass of one of the element is fixed. The ratio by mass of other element is varied. As a result, you are getting different products. This is one simple example, taking hydrogen and oxygen. In the same way, it can be explained by taking nitrogen and oxygen. Just observe here. Nitrogen and oxygen. Nitrogen and oxygen. See, you take nitrogen. Usually nitrogen, it should be in the form of N2. Half N2 means nitrogen only. Then half O2, it is O, it gives NO. Okay. Yeah, half N2 means N. Half O2 means O, it gives NO. Right. What is the difference in this? No difference. Usually we are taking the reactants in how it is available in the nature. Nitrogen does not exist in the form of N, or oxygen does not exist in the form of O. It exists in the form of N2 and O2. That is the elemental state of nitrogen and oxygen in the nature. The same we are taking in the form, but it is written half and half here. Okay, N, nitrogen. This nitrogen is combining with oxygen. Mass ratio, they are telling a mass. What is the mass of nitrogen? Nitrogen atom. Nitrogen atom, its atomic mass is 14. Gram atomic mass, we are expressing that mass in gram, that is a gram atomic mass, that is 14 grams. You take oxygen. What is the mass of oxygen? Mass of oxygen is 16. Now, nitrogen and oxygen is combined to give NO. It is one of the oxide of nitrogen. Its mass is equal to 30 grams. Mass is equal to 30 grams. Okay. You take the same reagents but different mass. For example, N plus O2 giving NO2. What is the difference between first and second reaction? If you observe carefully, nitrogen, no changes. Oxygen and oxygen, but here oxygen is half O2, here is O2. Complete full molecule is consumed. What is the mass? It is 14 grams plus the mass is 32 grams. Here mass of nitrogen is fixed, but the mass of oxygen is varied. Mass of oxygen is varied. So it is 14:16. 16, 14 is to 32. The ratio, if you compare between the two reaction, which is equal to 1 is to 2 ratio, NO and NO2. NO and NO2. Okay. Just by varying the mass of oxygen, the product is different. It is not same. This is said to be law of multiple proportion. When the same elements are combining together, but the mass ratio of one of the element get varied, we are getting different products. But both the products follows a simple whole number ratio. This was given by John Dalton. This theory is said to be law of multiple proportion. Law of multiple proportion. So we discussed three laws. One is law of conservation of mass. That is, matter is neither be created nor be destroyed. Second law is law of definite proportion. It means that irrespective of sources of the compound formed or produced, the ratio of composition of element is fixed with respect to their mass. That is law of definite proportion. Law of multiple proportion, that is the third one. It states that when the two different elements are combining, where the mass of one of the element is fixed, by varying the mass of the second element, we get the different products. But in both the products, it follows a simple whole number ratio. Usually, see, this reaction is given to you, N plus O2 giving NO2. How this question can be asked? So N plus O and NO is both the reactions are given. You should identify which law by considering both the reactions. If you consider both the reaction, so it should follow law of conservation of mass. They have given that option also. Law of definite proportion, law of multiple proportion, and Gay-Lussac law is the fourth option might be given. So with respect to first and two, you should compare both 1 and 2. Which law is the question? So when you are considering both the reactions, first and second, it is law of multiple proportion. Why means in the first it is mass of nitrogen, in the second the mass of nitrogen, both are fixed, and the oxygen mass is varied, the products are different. So when you compare first and two, it is a law of multiple proportion. When you take the first law, or if only one reaction, it is law of conservation of mass. If mass is given, it is balancing right hand side as well as left hand side. If it is balancing, it is law of conservation of mass. Law of multiple proportion, how they give? So different sources are given. NO2 obtained from combustion of nitrogen, obtained from burning of fossil fuels, and by nitrogen fixation mechanism through a nature. So such sources are given, but the product is only one nitrogen dioxide, NO2. So this is law of definite proportion. Law of definite proportion. Why means irrespective of different sources, the composition of the compound is remaining same. This is how we should apply the theory to the question to get the appropriate answers. Later it will be discussed one by one. Okay, so we discussed three different laws. Now we are shifting to another law, that is Gay-Lussac's law. This is law of gaseous volumes. What is the meaning and statement of Gay-Lussac's law? This Gay-Lussac's law was given by Gay-Lussac in 1809. It is also called law of gaseous volumes. Why it is to be stated like this? Why it is a loss of gaseous volume? Take a simple example. So, hydrogen H2 plus O2 is giving, if you take 2 hydrogen, 1 mole of oxygen to give 2 molecules of H2O. Okay, 2 means with respect to volume, it is a 2 volume you have taken. It is a G, gas. If it is written G means it is in the gaseous state. O2 G means oxygen is also in the gaseous state. H2O G means water in the form of a vapor, that is vapor state is represented as G. Just observe this reaction carefully. How many volumes of hydrogen you have taken? No need to worry, it is given in the stoichiometric equation. 2 parts of hydrogen gas. Fine. With respect to volume, O2 is mentioned, nothing is written here, it is nothing but 1 volume. Fine. Then how much is the product obtained? It is a 2 volume of water, that is vapor. So it is 2:1:2 ratio. So what it states is the question. This Gay-Lussac's law states that whenever gases react together, volume of reacting gases as well as the products, if they are gases, bear a simple whole number ratio provided all the volumes of measured under similar condition. So this reactant is also gas. This is also reactant, it is also gas. This is also product, which is also a gas. If the reactant as well as a product is gas, in such chemical reaction, the mass and the volume of reactants and the volume of the product which is obtained, it follows a simple whole number ratio. Condition is mentioned. So if it is to be measured under similar condition, same temperature, under same pressure, it should be measured, then it follows simple whole number ratio. What is the meaning of simple whole number ratio? Just observe. You have taken 2 moles of hydrogen, 1 mole of oxygen. You got 2 moles of water, that is a vapor. It is not 1.5, it is not 2.5, or it is not 3.6. This also follows simple whole number ratio with respect to the volume. This was given by Gay-Lussac's law, or the law of gaseous volume. So this is a simple example which explain Gay-Lussac's law. How to identify whether it is applicable for Gay-Lussac's law, law of multiple proportion, definite proportion, or definite composition? Very simple. Observe here. This is given state, gaseous state is mentioned. The volume of the reactant is also given. Volume of a product is also given. If you get this type of a ratio with respect to reactant gases and the product gases, this question is related to Gay-Lussac's law. It is not mean that definite law of proportion or law of conservation mass. 100% it should follow law of conservation of mass, law of definite proportion. If it is a definite proportion, different sources should be given. They have not given different sources means, so that part is not applicable. So it is with respect to Gay-Lussac's law. So this is a 4th one. We have one more law, that is Avogadro's hypothesis. It is also called Avogadro's law. What is the meaning of Avogadro's law? So for this also, let us take a very simple example. Very simple example. See, nitrogen gas. Nitrogen gas. N2 means 2 atoms of nitrogen. It is nothing but one molecule. One mass of one nitrogen is 14. 2 nitrogen atoms are combined, so mass is 14 plus 14, which is equal to 28. 28 gram molecular mass. You have taken 28 grams. That is nothing but one volume. O2, oxygen gas you have taken. How many atoms? 2 atoms. O. What is the mass of one oxygen? That is 16 plus 16. It is equal to 32 gram. Here also one volume. Same volume you have taken. Then you take carbon dioxide gas. How much? 1. Carbon dioxide, carbon is, it is 12 plus oxygen 2 atoms, that is 32, which is equal to 44 grams. Here the thing is, you have taken 3 types of gases: nitrogen gas, carbon dioxide and oxygen. So one volume, one volume, one volume. Volume is same, but the mass is not same. Mass of nitrogen is 28, carbon dioxide is 42, oxygen is 32, but the volume is same, 1 liter, 1 liter, 1 liter. So here a well represented. So in a balloon you have taken 1 liter of nitrogen, 1 liter of oxygen, 1 liter of carbon dioxide. But mass is different. The thing is, here the common thing is the temperature and pressure is constant. Temperature is 273 Kelvin, 1 atmospheric pressure. When the different gases of same volume is taken under same temperature and pressure, see what you get. You get equal number of molecules. So mass is 28, this is 32, it is 44. So what we think, 44 grams means it should be a more number of molecules. The 28 means it should contain less number. No. So irrespective of the gases, when you take the same volume under same condition, temperature and pressure of different gases, then total number of molecules in this cylinder or in the balloon, it is same number you will get. This is, if it is an X number, this is also X number, this is also X. Number of molecules remains same when you take a same volume of different gases under similar condition. This was given by Avogadro hypothesis. It is also called Avogadro's law. That is, V is proportional to N. V means volume is proportional to M means number of molecules, number of moles. That is the concept. It will be discussed later. So this is called Avogadro's hypothesis. So significance of Avogadro hypothesis means this law helped to remove anomaly between Dalton's atomic theories and Gay-Lussac's law of volume. Dalton's atomic theory, it will be explained in the later classes. These are the hypotheses. So whether it is right or no, right or wrong, we don't know. But they have proposed the theories. It may not applicable in all the cases. In such cases, those points will be considered as anomaly. It is impractical. It cannot be applicable for all the things. So in the same way, some of the theories or the points proposed in the Dalton's atomic theory cannot be applicable. This mistake was rectified with the help of Avogadro's hypothesis. So it reveals that common elementary gases like hydrogen, oxygen, nitrogen, they are diatomic. So what is the meaning of a diatomic? So it was not mean that oxygen exists in the nature not in the form of O, it is in the form of O2. Nitrogen not in the form of N, it exists in the form of N2. This diatomic concept was well explained with the help of Avogadro's hypothesis. These are the 5 different laws which governs the chemical reactions. Either any one of the laws should be followed, or all the laws should be followed in many of the cases. So this is said to be law of chemical combinations. So which is the first? See, this is the first law of conservation of mass. Second one is law of constant composition or definite proportion. Next is law of multiple proportion, Gay-Lussac's law and Avogadro's law. So these 5 laws are very important. We can expect questions for competitive exams. So in the next session, I will be taking the different concepts of the same chapter. Thank you.